Hello everyone, myself Vikas Prajapati from DY Patil College of Engineering, Akoti. Today we will learn about what is the single plate clutch. Single plate clutch, which is a friction clutch used for the manual transmission vehicle to engage and disengage of the engine. Purpose and types. Purpose. Clutches transmit torque from the engine to drivetrain. They enable gear changes without damage. Types. Single plate, multi-plate, cones, clutch dogs. Components and material. Clutch disc. Friction material bonded to a steel plate transmit torque. Pressure plate. Applies force to the engage the clutch disc with the flywheel. Flywheel. Rotate with the engine providing a friction surface. Release mechanism. Disengage the clutch via lever or hydraulic system. Working principle of single plate clutch. Single plate clutch work on the principle of friction. When the clutch pedal is pressed, the pressure plate move away from the flywheel and release the friction plate and disconnecting the engine from the transmission. When a pedal is released, the pressure plate apply pressure to the friction plate, engaging it with the flywheel and connecting the engine to the transmission. Advantage of single plate clutch. Easy to design and maintain. Cost effective. Lower manufacturing and replacement. Fit well in passenger car. Good torque capacity. Disadvantage of single plate clutch. Friction material can wear quickly under heavy use. Heat generation. Less effective cooling compared to multi-plate design. Torque limited. Lower torque capacity. Not ideal for high performance vehicle. Slippage risk. Can slip during heavy load or poor maintenance. Application. Where are they used? They are mostly used in passenger vehicle, light commercial vehicle, motorcycles. Maintenance and troubleshooting. Inspect. Check friction material wear and pressure plate condition. Adjust. Ensure proper pedal free play and cable hydraulics setting. Replace. Change run-out disc and faulty component promptly to avoid damage. Lubricate. Apply grease to points and bearing to. In this derivation, we will learn a derivation of torque transmitting capacity. First is uniform pressure theory. Capital D. Capital D is represent outer diameter of friction disc. Smaller d represent inner diameter of friction disc. Smaller p is intensity of pressure at radius and bigger p is total operating force. Mt is represent torque transmitting by the clutch. In this, intensity of pressure P at radius r may be constant or may be variable. Consider an elemental ring or of radius r and radial thickness dr, which shown in figure 11.4, where the elemental friction torque is equal to 2 pi mu in bracket p r square dr. By integrating an expression A, we get P is equal to 2 pi integrating lower integrate d by 2 upon upper integrate d by 2 P r dr. By integrating the expression B, we get Mt is equal to 2 pi mu integration lower diameter d by 2 upon upper diameter d by 2 P r square dr. First is uniform pressure theory. First is uniform pressure theory. In this case of new clutch employing a number of spring, the pressure remain constant over the entire surface area of a friction disc. With the assumption of P is assumed to be constant. This constant pressure distributed is illustrated in figure 11.5a. We get this is a diagram of pressure distribution. By dividing equation 11.4 by equation 11.3, we get mt is equal to mu p upon 3 capital D cube minus smaller d cube upon capital D square minus smaller d square. Second one is uniform wear theory. Uniform wear theory, according to the second theory, it is assumed that the wear is uniformly distributed over the entire surface area of a friction disc. This assumption is used for runout clutch. This axial wear for the friction disc is proportional to the friction work. The work done by the
friction force at a radius r is proportional to the frictional force and rubbing velocity, where n is speed in revolution per minute. Assuming speed n and coefficient of friction mu constant, where is uniform, pr is constant. The pressure distribution according to the uniform wear theory is illustrated in figure 11.5b. From equation 11.1 we get P is equal to pi PAD upon 2 capital D minus smaller d. From equation 11.2 we get MT is equal to pi mu PAD upon 8 this capital D square minus smaller d square. Dividing equation 11.7 and 11.6 we get MT is equal to 2 mu p upon 4 capital D plus smaller d. The above equation give the torque transmitting capacity for a single pair of contacting surface. There are two phases for the wear mechanism in the frictional lining. First is when the frictional lining is new, uniform pressure theory is applicable where P is constant. Second is since the pressure is released, there will be the no further wear at the outer edge. The wear will be not take place at the inner edge due to contact of pressure plate. Based on above decision, the following observation are made. First is the uniform pressure theory is applicable only when the frictional lining is new. From equation 11.8 can be written following ways. Mt is equal to mu p Rf, where Rf is a friction radius. Similarly, equation 11.5 can be written in following way. Mt is equal to mu p Rf. From that we get the Rf equation 1 by 3 capital D cube minus smaller d cube upon capital D square minus smaller d square. From this table we get the equation of D capital D smaller d and the formula of 1 by 3 capital D cube minus smaller d cube and capital D square minus smaller d square. There are two assumptions. A comparison of equation A and B in the above table shown that the friction radius for a new clutch is slightly greater than for the runout clutch. Second is since the frictional radius of a new clutch is more, the torque transmitting capacity is also more. From this PPT, we conclude that the single plate clutch is widely used and effective type of frictional clutch that provides smooth engagement and disengagement of an engine. From the transmission, while it has some limitation, its simplicity, low cost, and easy to maintain make it popular choice for many applications. We have taken the reference of V.V. Bhandari of design of machine element and we have taken some from Wikipedia. Thank you.